Welcome to this explainer. Today we're going to absolutely unravel a profound cosmic mystery, and we'll do it by completely shifting our perspective on reality itself. If you've ever caught yourself wondering how the universe actually operates at its most absolute fundamental level, well, you're in exactly the right place. We are tackling the foundational crisis of modern physics, and more importantly, we're looking at a groundbreaking, completely mind-bending way to finally solve it.
Let's just dive right in by asking a seemingly simple question, but be warned, this is the exact question that literally broke the minds of the world's greatest physicists. Is reality made of many things or just one? Now, I know what you're probably thinking. Obviously, it's made of many things, right? You are separate from the screen you're looking at, which is separate from the chair you're sitting on. But when physicists started looking at the very smallest building blocks of reality down in the quantum realm, that obvious, everyday intuition aggressively fell apart. And honestly, nobody was more bothered by this than Albert Einstein. He famously used these exact words, spooky action at a distance, to express his deep discomfort with the strange, seemingly impossible behavior of particles in the quantum realm. He was talking about entanglement, of course. That weird phenomenon where if you measure one particle, its partner instantly knows and reacts, even if it's all the way on the other side of the universe. To Einstein, this was completely unacceptable. Why? Because it heavily implied that information was traveling faster than the speed of light, a cosmic speed limit that he himself discovered. To fix a seemingly broken universe, we're going to follow this structured map. 1. The historical quantum impasse. 2. Einstein versus Bohr. 3. The third way emerges. 4. Layer 1, ontological monism. 5. Layer 2, phenomenological pluralism. And finally, 6. Reconciling the giants. Section 1. The historical quantum impasse. Let's look at the foundational crisis that forced scientists into two completely irreconcilable camps. So this ultimate dilemma was exposed by the Einstein-Podolsky-Rosen, or EPR, paradox. It's a foundational crisis exposing the profound tension between the mathematical completeness of quantum formalism and the principle of locality. On one side, you have the math of quantum mechanics, which works perfectly. But on the other side, you have the principle of locality. That's the rule that physical processes are constrained by the speed of light and that things have distinct spatial coordinates. Physicists essentially had to choose. You either break the universe's ultimate speed limit or you admit that quantum math is just an incomplete description of reality.
Section 2. Einstein versus Bohr. A clash of titans over the fundamental nature of physical existence.
This binary choice split the scientific community right down the middle. Interpretation A. Completeness via non-locality. That was Niels Bohr. He simply accepted the spooky action, the non-locality, in order to keep quantum mechanics as a total, complete description of reality. Then we have interpretation B. Locality via incompleteness. That was Einstein. He argued that since non-locality is physically impossible, quantum mechanics must just be a statistical approximation. Basically, he believed it was incomplete and hiding deeper, local hidden variables that we just didn't have the experimental tools to see yet.
This disagreement built toward a massive breaking point. First, the EPR paradox forms this strict binary deadlock. Then, along comes Bell's theorem, which actually mathematically disqualifies the possibility of Einstein's local hidden variable theories. And finally, Alana Aspect's physical experiments step in and confirm the statistical predictions of quantum mechanics. So looking at this, it really seemed like Bohr had won, and Einstein's interpretation B was totally shattered. Section 3. The third way emerges. What if this historical stalemate wasn't actually a failure of reality, but a failure of our perspective? Think about this crucial, provocative question for a second. What if Bohr and Einstein were both right? Even though Bohr was historically considered the definitive winner, what if we didn't actually have to choose between locality and completeness? Is there a third option that puts both of these scientific giants back on equal footing? What if quantum mechanics is incomplete, but reality is also non-local at the same time? To solve the paradox, we basically have to zoom out. We need to introduce a new tiered structure of existence known as the two-layer model. This paradigm suggests that these apparent contradictions aren't flaws in reality at all. They're actually artifacts of an incomplete ontological map. They're glitches, essentially, caused by the fact that we've been looking at things the wrong way. We have to draw a hard line between the absolute foundation of existence and the domain of human observation. Section 4. Layer 1. Ontological monism. Let's explore the foundational tier of this new map. So, in philosophy, monism just means one.
ontological monism posits a complete reality consisting of a single foundational object, where the concept of locality is rendered completely irrelevant. Because there is literally only one object at this base layer, there is no distance to traverse, and there's absolutely no other object to interact with. Think of it like a single, massive, continuous ocean. One single object. No distance, no other. This means that what we think of as spooky action between distant particles, it's actually just the internal dynamics of one singular entity behaving according to its own properties. If everything is ultimately just one single object, then entangled particles aren't somehow communicating across vast distances faster than light. They don't need to communicate at all because they are the exact same thing. This beautifully provides the logical completeness that Einstein so desperately wanted, but it does it by bypassing the paradox of distance entirely.
Section 5, Layer 2, Phenomenological Pluralism. Looking at the second tier of the model.
Now, obviously, we clearly experience a world full of separate, distinct things, right? So we have to look at the second tier of the model, phenomenological pluralism. This is the domain of human observation, characterized by the presence of many objects which serves as a perspective-driven manifestation of the underlying whole. This is the layer where quantum mechanics actually lives. It represents a fragmented, inherently incomplete, yet non-local view of the foundation. When we look at the universe, we see many separate things, electrons, photons, us as observers. But this model is telling us these are not independent primary entities.
Many objects, an incomplete, perspective-driven filter of a unified whole. You see, the perceived incompleteness of quantum math isn't a failure, it's just the necessary consequence of our human perspective sampling a unified one as a collection of many parts. Our human viewpoint acts kind of like a prism. It shatters the underlying singular reality of Layer 1 into this perspective-driven manifestation of multiple objects in Layer 2. So if we run our math based on the assumption that there are multiple separate objects, of course those objects will appear to obey non-local spooky rules. It's precisely because our math is fragmented. Section 6. Reconciling the giants. How this dual-layered synthesis resolves the debate. Now, we can finally see how this dual-layered synthesis perfectly resolves the greatest debate in 20th century physics. Both giants were simply describing different aspects of the exact same complex truth, without even realizing it. In Layer 1, ontological monism, we have one singular entity, where the role of locality is irrelevant. There's no distance. It's complete and objective, which perfectly validates Albert Einstein. But in Layer 2, phenomenological pluralism, we have many objects, electrons, observers, behaving non-locally through an incomplete perspective-driven filter. And that perfectly validates Niels Bohr's intuition.
This is the contextual completeness synthesis. Einstein gets his complete, objective reality salvaged by Layer 1. Meanwhile, Bohr's non-local, perspective-driven quantum description is validated as the absolute accurate view of Layer 2. Neither giant suffered a failure of logic here. They merely lacked a dual-layered map. It was just a clash of deeply accurate insights directed at totally different ontological tiers. Without this layered map, their positions looked totally irreconcilable. But with it, we finally get contextual completeness. As we wrap up this explainer, I want to leave you with a final thought to ponder about the true, hidden nature of our existence. If our reality, this incredibly complex universe we see around us with its galaxies, stars, and tiny entangled particles, if all of that is merely a filtered, fragmented perspective of one single unified object, what else is our incomplete map hiding? What other deep truths about reality are waiting right there, just outside the edges of human perception? Thanks for joining me on this journey, and definitely keep asking those big questions.